Hello, hello. Am I audible? Hello, am I audible? Hello. Okay, so let's start with today's question. So the first question was buying tickets. Chef wants to buy tickets to a sports game for K people, including himself. The sports game has n total seats, number from 1 to n. The eighth seat cost A of I rupees. However, several seats have already been bought because chef was late to the task. Here you are given a binary string as where s of I is equal to 1 if ith seat has already been bought and s of I is equal to 0. Okay, so among the remaining seats, what is the minimum cost chef has to pay to buy k seats? It is not required that the seat be consecutive or any other property. It may be impossible to buy k seats. Okay, so what we have to do here? So here we were given an array. So here what we were given some array, some numbers we can say. So these were seats and there were cost to buy each seat. Suppose let's say this seat was okay. So it was something like this. So each seat has a cost attached to it. Okay. So what we have to do? We have to buy K tickets. Okay. But we are also given a string. So basically what this string shows, this string shows that if it's one, then it's already been taken. So this string is taken. These three seats are taken, so we can't take it. Okay, so what we want to do? We want to buy K seats, and for each seat, what would be the minimum cost we can buy these K seats? Okay, so we can do greedy here. So by greedy, I mean that suppose if we want K seats, okay, I have some options. Let's say I have this many. Just a second, please. Okay, so let's continue. So where were we? Okay, so we want K seats. We want K tickets. Okay. So if suppose if I have five tickets available, and if I want K tickets, then wouldn't it be best that I would pick the less expensive one? Okay, because it's mentioned in the question that the what we say the position of the ticket doesn't matter. I just want three tickets. So it would be best to just take the three tickets. So what we have done here, let me show you my code. Okay, so what we have done here, we have taken the input n and k. Uh, Here is the input of the vector. Now for the string. Now as we can't take all the options, okay, because some seats are already been bought. So only, we will only consider that strings which are still left to buy. Okay, so whose s of I is equal to 0 means this seat is currently available to be bought. So that's why we will put it in the set. And if we can't buy K tickets. So if the available seats are less than K, then simply we will output -1. And if we can buy tickets, K tickets, so we would buy the smallest K tickets. Okay. So that's why what I'm doing. I'm picking the smallest element of smallest price of everything available, and then I'm erasing that price. Okay. So we are basically picking the least expensive K tickets. Okay, so that was for question one. Okay, so let's move on to question two. So it was erase and maximize. Okay, so the okay, तो अब इस क्वेश्चन में हमको डाइस दिए है एन डाइस वी आर गिवन विथ एन डाइस ओके सो लेट्स से we are given with n dice, so every dice can have number from 1 to 6. Okay, so in this question what we have to do, what we are doing, we want a sum as. Okay, let's say that sum is x. Okay, so what we want some x. So by using some digits, let's say if the x was 8, then if I have chosen this 4, okay, so by these two numbers I can create 8. Okay, so the what was question? Uh, you must choose one face from each dice such that the sum of values of the chosen face equals to exactly s. Okay, note that the country constraints on S, that is always possible to make such a choice. Okay, so what we have to do? Uh, okay, we are given n dices. Each dice can go from 1 to 6. Okay, so from this 1 to 6 dice, we want a number on each dice. So these are n dices. Okay, so we want one number in each of these dice. It can be anything, but the total of this means summation of every number should be equal to x. Okay, I should be 0 to n-1. So in short, this was the question that we want summation of every number to be equal to x. And now we whatever number was here, suppose if x was here, let's say 7. Okay, no, let's keep it 8 only. So suppose if there were 7 dices and we want the sum 8. So what we can do? We can either let's put 1, 2, 3, 4, 5, 6, and now 2 here. Okay. So what we have done, we have put on everything, and uh, what was the next part of the question? Suppose the number was 8. We have got a formation of this. Now what we are doing, we are removing these elements. So now we can't take 0, 1 on this dice. Okay, so we can't take 1. So what can we take from this dice? We can take 2, we can take 3, we can take 4, we can take 5, and we can take 6. Similarly for this, this, and this. Now for 2, we can take either 1, 2, we can't take 2, sorry. So 1, 3, 4, and so until 6. Okay, so what they did, whatever number we have chosen, we are replacing it with 0. So basically, we are not choosing that element again. Okay, so 0 is the smallest among these. Okay, so it will not contribute to our answer. So what we are doing, if we can't choose that element which we have chosen earlier, now we have to maximize our score. Okay, so after applying this, what is the maximum we can get? Okay, so what I'm saying that after applying these operations, let's say after suppose the sum was 8, so what we have done 1 1 1 1 1, so it's 6, and at last we have put on 2. So the sum is 8, but the question is now we can't take any of these digits on that dice. Okay, so if I can't take one, I want maximum. I want this sum to be maximum. So if I can't take one, then what should I take? Isn't it best that I take 6? Because if I want maximum, then I would simply take the maximum available. I would simply take the maximum available number. Okay. So if the numbers were 1, 2, 3, 4, and 5 and 6. Now to achieve it, what we have done? We have put on 5 ones and 1 2. So at this position, we have put on 1. So what can we can't take this. Okay, so what would we take? We would take the maximum among available 6. For this also, we would take 6. For this also, we would take 6. For this two also, we would take 6. Okay, so total 6 times we have taken 6. And here we can't take 2, but still we can take 6. So what we are taking? 6 into 7. That would be our answer. Okay. So if you can observe one thing here, that no matter what I put here, until it's not 6, I would take 6. You are getting what I just said. I don't care what I take here. 1, 2, 3, 4, 5, 6. I don't care what number I take here until it's 6. Because if I have taken 6, then I can't take 6. Okay. So let's suppose the number we have to make was 8 and the elements available were 8. So we would have taken 4 twos. Okay, so now we can't take 2 in any of the dice. We don't care of this. We only care about 6. Because if we can't take 2, if we can't take 3, it doesn't matter. We want maximum, so we would take 6 every time we can. Okay, so whatever time we can, we would take 6. Okay, so the answer now the problem simplifies to this. That is, if we don't care about the number. What we only care that we want every time 6. Okay, so 6 here, 6 here, 6 here, 6 here, and 6 here. Now, what can be the case that we can't put 6 in any of the cases? Means what I'm saying that if I can't take 6 here, that means that I have included this 6 in earlier sum. Okay, so whatever the value was x, this 6 was utilized in making that value x. Okay, so now how can we say that? Okay, so notice one thing. If I put, let's suppose if I want 6 as a last value, what is the maximum value I can take here? It's 5. So at every index, I can take maximum 5. You getting what I did here? So suppose there are 6 values. Okay, so let's say this was the question. Okay, 2 and okay, this is a better. Okay, let's take these 2 examples. Okay, so one is okay, so the one is 2 and 3. Okay, so what we are 2 and 8. So how many values are there? So there are okay. So let's suppose there are 2 and 3. Okay. Okay. So we want to fill these two blanks with the question was 2 and 8. So we want to fill these two blanks with one number, and after filling that number, we can take anything that is not used earlier. Okay. So what we want maximum here, 6 and 6 also here. So if I can take 6 in both the places, then I would get the answer for 12. So what I want, I can't put 6 here and I can't even put 6 here. So what is the max number I can get? It's 5 and 5. Okay. So what I'm saying, if we are to make two numbers whose sum is 8. So if I take 5 here and 3 here, then I am done. Okay. It makes 8, and what I want to be maximized, the remaining number. So I can take 6 and 6. Okay, so this is a valid configuration. Now, so here the answer is 12, you can see. Okay, but here comes a twist. What if this was 11? Okay, what if this was 11? So now I have to make what is the maximum number I can make here? If I take 5 and 5, still I can't make 11. This is max 11. This is 10 only. So I have to sacrifice 1 6. Okay, so I have to sacrifice 1 6. So now if I have put on 1 6 here, then I can't take pick 6 here. So what would be my next best element? It would be 5. Okay, so here that's why answer is 11. If I take for next task, which is 18, so it's 3. Okay, so if I have to pick from 3 numbers, so what can these 3 numbers be? The maximum I can get is 666. Okay, but I want to get 18. So if I put 555 here, then also I am missing by 3. So I must update 3 of these to 6. Okay, so if I update these 6, these to 6 and these to 6. So I have updated every 5 to 6. So now I can get 18. But now I can't put 6 here because I have already put on 6 ahead. So what would be my next best value? It would be 5. Okay, so that's why the answer is 15 here. Okay, and similarly for the fourth case. So in short, what we are doing, okay, let me show you my code. So that was the observation here, that if we can't put 6, then only we can, what is the maximum number we can make here without sacrificing our 6? So it would be 5 into n. Okay, so if our number is, okay, so if our number is less than 5 into n, less than equal to, so if our number is less than equal to 5, we, no matter what we take, okay, we can get our answer to be n into 6. Okay, okay. So if I can take what is the maximum number I can get here without sacrificing my 6, without sacrificing any of my 6's, so that would be 5 into n. Okay, so if the number we have to make is less than this, then the answer would be simply 9 into n into 6, because we can make every element 6 in the last array. Okay, now what if we can't, if it's greater than 5 into n? Okay, so it's greater than 5 into n, then we have to sacrifice some of our 6's. Okay, so suppose let's say n was 50, let's say n was 15, 16, okay, and we are with three values. So if maximum I can get is 15, but if the number is 16, then how many six I have to sacrifice? That would be what is the number given here into 5 into n. Okay, so this was the this many sixes I have to sacrifice. So if the number was 16, then the answer would be 1. So I have to make this 1, 1, 5 to 6. So now what is the maximum number I can get? So the maximum number I can get is, earlier what was the maximum number I would have gotten? That would be n into 6, because we can take every n equal to 6. But now how many sixes we can't take one? Means uh, this was the max we can get, but now we have used this many sixes. So for this many sixes, what we can do? What was the difference? Earlier, this was giving summing me 6. If I have put on 5 here, then I can put 6 in a last answer. But if I have put on 6 here, then what would be my next best? It would be 5. So what would be the difference? It would be of 1. So simply, if this many sixes I require to make this number, then in our final answer, the number would be less by this. Okay, so it would be 5 into n. Okay, so if I simply write this one condition, okay, so that if this was the case, n into n, if we take both, okay, if we take both the input, now if k is less than equal to 5 into n, that is, we can take every element as 6, then we would have simply outputted 6 into n. Okay, that was it. But now if we have taken some 6, so if k was greater than 5 into n, then as I said, we have to sacrifice some of our sixes. So now the answer would be the max answer from earlier minus how many sixes we have sacrificed. Okay, so now the answer would be, the max answer earlier was 6 into 8. How many we have sacrificed? We have sacrificed this many. Okay, so if I sum it up, you can see. Okay, so this was it for the second question. I think the first 2 to 3 questions are just greedy. If you know that what is the best way to pick, that would be greedy. By the way, this was my code for the which I submitted for this contest. So what I did, as I told, that if we can find something that is less than given number. So here I did without the formula in the contest. What I did was I traversed from 1 to 5. So what I checked, if I put one all fives, then is this sum greater than that? So if this sum is smaller, then the answer would be simply n into 6. But if we can't get any answer, so here the last item would be 5. So if the number is still bigger than 5 into n, then we can't, we have to sacrifice some sixes. So that's why what I did here. So this is remaining. Okay, so this many sixes I have to sacrifice. So that's simply this. Okay, so that was for second. So now let's move on to the third question. Okay, if you have any doubt, you can ask. Okay, so let's continue. So let's not erase anything. Okay, so in question 3, equal elements. An array B of size 2 into m is good if the following condition holds. For each I, 1 is to 1, 2, 3 till n, p of 2i minus 1 equal to p of 2i. Okay, so this is example. I will explain you what it's saying. So you are given array of length. Find the length of longest subsequence of a which is good. Okay, so let me explain the question. So what this question is saying? In this question, what we are given? So we are given some numbers. Okay. Okay. So in this question, what we are given some numbers, and any array is good if its form sequence like this. Means every two numbers are equal. Okay. So the condition here, this what this condition means is that any array to be good, it should be in form this. It can be anything, but the adjacent number should be same. So every index, these both should be same. First and second should be same. Third and fourth should be same. Five and six, fifth and sixth element should be same. Okay, this should be same. Okay, so this was the question. So this is called a good subarray. So now we are given a random array. Okay, it can be anything. Okay, so we are given a random array, and we have to find what is the longest subsequence. Subsequence means any array formed without changing the orientation. So suppose if I choose to remove this. Okay, so the new array I would get is 3, 7, 5, 6. Okay, so basically subsequence means any from this array we can choose to eliminate any of the numbers, and whatever array is left is our new array. So in short, subsequence means we can't change the order of any elements. We can choose to remove some elements. Okay, so what we have to find? We have to find what is the maximum good subarray we can get. Okay, so if I take the example, okay, so if I take the example 1, 1, 3, and 3. So what is the maximum good subarray I can take here? It's this whole, if I take this whole array, then it would be good because all the conditions are satisfying. The 1 and 1, so first and second are same, digit set, number at third and fourth are same. Okay, so here in this case, answer would be 4. Now for next, it would be 2, 2, and 2. So what is the max I can get here? The maximum I can get here is 2 only, because in the question it says, you can see here 1, 1, and 2. So all the it should be of even length only, and every adjacent element should be same. Okay, so what I can do, I can just take 2 and 2 only. Okay, so what was the next? Okay, so here the answer was 2 only, because I can take any two. I can take these two, I can take these two, or I can take these two. Still the answer would be 2 only maximum. So now 1, 2, 1, 2, 3, 2, 3, 4, 4. Okay, so 1, 2, 1, 2, 3, 2, 1, 2, 1, 2, 3, 2, and 3, 4, 4. Okay, let me write 1, 2, 1, 2, 3, 2, and 3, 4, 4. Okay, so what is the maximum I can get here? Okay, suppose if I take this one. Okay, if I take this one, then what is the next element I should take? It should be this only. So it would be 1. Now if I take these two, okay, so now what is the next element I can take? It is 2 only. Okay, so I have taken 2. Now we have reached here. What is the next element I can take? If I take 3, then there is no next 3, so we can't take 3. Okay, so here we can't take 3. Now let's move ahead. If I take 4, then the next element I can take is 4 only. Okay, so there is a 4, so we can take it. So this would be my maximum if I have chosen from 2. I mean 1. Okay, so here the answer is also 6. Now if I have skipped this one, if I have not chosen this one, and if I have picked the next element 2, then what is the next element I have to choose? It's these 2. Now if I have choose these 3, Then the next element I have to choose is this 3. Okay, and 4 and 4. So this would also give me 6 only. So by this we can say that the maximum is 6. Okay, but we can't check for by creating every subarray subsequence, because how many possible subsequence there would be? If I say there are n subsequence, then the number of possible subsequence are 2 to the power n minus 1. Okay, that is if we are considering all the non-empty subsets, then the subsequence that can be formed is 2 to the power 9 minus 1. Because for every element we have a choice, either we take it or not take it. So it's 2 into 2 into 2, 2 into n. Okay, so that would give us TLE, so we can't iterate through every subsequence. So is it clear? So now what can we do? So suppose for any index, suppose I am at 3. Okay, suppose I am at 3. So if I have to take this 3, okay, if I have to take this 3, if this 3 is the first element, okay, so then what should be my next element? That should be this 3. Okay, because I am bound by my bound by my condition. Okay, so if I know that what was what was the best answer behind this 3. Suppose this 3 is the second element. Okay, so how should I explain this? Okay, so let's say that we have to create something like this. Okay, and let's say this was our initial array. Something like this. Okay, so if I take this one, then what are the possibilities? One possibility is that uh, if I have already chosen one earlier, so let's consider. By the way, it was I solved this by DP. Okay, so let's consider two conditions. One is number, and the second is whether this number was first or second. Okay, so what I mean by that, suppose if we are at this one. Okay, suppose if we are at this one. So if I want to include this in our answer, so what are the two cases that I can by which I can include? The first case can be that if this is if there was a string, let's say there was a array of 1 1 2 2 before this, so I can add that this to this. Okay, so I can simply append this one here. Or what is the second case I can get is, the second case is I can if I can append it to already included one. Okay, so if I know what was the best answer before this, so if I want to append it to already appended one, so if I know what is the best answer before this, then I would simply increment this by 1 plus 1. So that's why we are taking two states. Okay, so one option is we are appending it. This is the first element which we are appending. So if you say in this, if we divide this whole array in 4 chunks, okay. So if the size of array is 2 into n, so what we are doing, if we divide the array in chunks, let's say this, we are treating this as 1 index, this as 2 index, this as 3, and this as 4. Okay. So if we are at, suppose we are at 2, okay. So what is the possibility? So for it can be either the first element or it can be second element. Okay. So if I want to append it to the second element, if I want to append it as a second element, then I can take the best answer till the first two and simply increment it by 1. Or if I want to append it to the current element, means if I want to append it as a first element, so what can I take? what was the previous best till here. Okay. So what is TP of number gives what I'm storing. I'm storing the best answer for this number. Okay. Okay. But what is TP of zero storing? It's storing best answer for this number as position one. For position one means if this item is this number is in its first position. Okay. And what is TP of one shows? It shows best answer for this number as position 2. So if I have taken this position 2, then it shows me what is the best answer. Uh, what is the best answer for the number 2 if it's ending at this 2. Okay, so how would the transition work? So what would if I choose to put it as first number? Okay, so if I choose this 3, if I want to put a 3 in first position. Okay, so if I have to put this 3 in the first position, what I can do? I can take whatever the maximum which I have already created. Okay, because I don't care what was the previous number because this is the beginning. Okay, so I what I can take the maximum number which already has ended. So whatever is the maximum. So if the maximum was 1 1 2 2 3 3 and one array was 2 2 4 4 5 5. Okay, let's say till now we have created these two. Okay, for just for example. So if I want to append 6 as first, then it doesn't matter if I append 6 here or here. The length would be same because we are just dealing with the length. Okay, what matters is the previous number should be completed. Okay, so whatever was the previous series, it should be completed. So it has the last pair should be as a whole. Okay, so it should be completed. It should be 3 3. Okay, so for position 1, we can simply take the best answer till here plus 1. Okay. And if I have to choose this as second position, then this number should be this number should have been picked earlier. So what we can do, what this DP stores, it stores the best answer till here. What this DP stores, it stores the best answer for this number as position 1. So if I want for position 2, I can simply add it to this. Okay, so now what it would be? It would be plus 1. Okay, so that was it. And then what I can do? I can update my maximum. Okay, and I can only take the numbers which are already ended. So my maximum would be this. Okay, so if you see in my code, if you see what I have done, I have just done this. Here my first stores. If I have chosen this number as first, here the numbers are till n. So we can create a vector of. I have created a DP of n numbers. Okay, what does first number stores? It stores that if I pick this number as a first number, then what would be my answer? Okay, so first stores as a first number and second stores as a second number. So initially I have created it -1 -1. So if it's still -1, that means I can't take this element as second number because I haven't picked it as a first number till here. Okay, so that's why this condition. So now what I did, I have first updated my second from first. So if I have picked this number earlier, then I can append this number to that answer. Okay. Now what can I do? I can choose the I can choose it to be as first number. So if I choose it to be first number, then what the maximum till here plus 1. Okay, so if I pick this as my first part of first number of a segment, so I till now how many segments we have gotten? Plus 1, because this would be the first. Okay, and we are updating our max with the second number because we are only considering the numbers which are whole, means what we are considering 1, 1, 2, 2, 3, 3. So if the number is full, means the segment is completed, then only we can take till here. Okay, we can't take from 1. So that's why from second. And at the end, what would be our answer? It would be simply the maximum we have chosen till here. Okay, so that was for question 3. So any doubts till here? Okay, so let's move on to the next question. Okay, so the question 4 was actually an interesting one. Okay, so what does the question say? It says twice greater an array of b an array b of length m is called good if 2 into b of I is greater than b of I plus 1 for all I from 1 to m. For example, 1 and 3 are good, but 1 and 2 and 1, 2 and 3 are not. Okay, so for sorted array B, we define f of B to be length of longest good subsequence of B. For example, array B 1, 2, 3, f of B is 2 because we can get what we can get longest subsequence 1 and 3. Okay, so you are given a sorted array of length n. Find the sum C for all C which are non-empty subsequence of A. Not that there are exactly 2 into n minus 1 such possible arrays. Okay, so answer is large, so we have to find modulo. Okay, so what does this question says? Okay, so this question says that what does this question says? So this question says that we are given an array. Okay, the array is of increasing order only. Let's say this was the array, or should I take something from the example? Okay, let's take this small one, 1, 2, 3. Okay, so suppose this was the array we are given. So what we are told? We are told that make all the subsequence from this. Okay, so what would it would create? How many subsequence it would create? One would be 1. The second can be 1, 2. The third can be 1, 3. Okay. Fourth can be 2, 2, 3, and 3. So how many subsequence we have made? So there would be 3 subsequence. Now what we are told for each this subsequence, for each of the subsequence, what we have to do? We have to find its score. Okay, so we have to find the length of longest good array. That means we have to find some score. And how is this score is find for a given subarray? For a given array? That is the longest prefix. Okay, so that is the longest length we can get till this condition is satisfied. Okay, so what is the condition? B of I should be B of I into 2 should be lesser than B of I plus 1. Okay, so if we look at all the subarrays, here 1 is possible, okay, and that is n. So answer will be 1. Here we can take 1, but we can't take 2 because if we take 1, then the next element should be greater than 2 because 1 into 2, 2, and the next element should be greater than 2. So here also answer is 1. Okay, here we can take 1. We can also take 3 because 3 is greater than 2. And if we take this one, then it should be greater than 2. So it is greater than 2. So we can take 2. Okay. Now if we take 2 as our first element, then it would give us answer 1 only. Now, if we take 2, 3, then also answer is 1 only because first element is 2, so second element must be 2 into 2, that is 4, so it should be greater than 4. But here it's 3, which is less than 4, so we can't take this element. Okay, so answer would be 1. Now, for these 3, the answer is 1. So, what is our total answer? 1, 1, 1. That is 3, 4, 5, 6, 7, and sorry, 1, 2, 3, 4, 5, 6, and 7. Okay, and what should be? Just a minute. 2, 3. Oh, yeah, one more. 1, 2, and 3. We were missing this. Okay, so here what we can take? We can take 1. Okay, now 2 we can't take. Okay, we can take 3 because the previous number was 1. So we can take 3 as our answer. Okay, so it would be 2 from here. So now what would be our answer? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so the answer is 9 for this test case. Okay, so now the question is, how can we do this? Okay, so we can't create every subsequence. Okay, because that would be 2 to the power n. And for each subsequence also we have to iterate through it once. So it would be 2 to the power n into n. So we can't do this. Okay, so this is out of the picture. Now what can we do? Let's what I can say that what if I count individually? Okay, by this I mean if I know what if I count this one, how many times this one would be considered in our answer? Okay, so if one is considered here 1 time, 2 time, 3 time, 4 time, and 4 time. So the answer for this one would be 4. Okay. Now if how many times this 2 is considered as answer? So that would be just 1 time and 2 time. Okay, so it would be 2. Okay. Now for these 3, how many times it would have considered as answer? So it would be 1 time and 2 and 3. So it would be 3. So if you sum this up, it would be 9. Okay. So if I can find the contribution by every index. Okay. So if I can find the contribution, how much contribution this index gives to the answer, how much contribution this index gives to the answer, how much contribution this index gives to the answer. So by adding that all, I can get the answer. Okay. So instead of creating every subsequence, what we have came up with, we have came up with a solution that how many times if we calculate for each index how many times it contributes to answer, then we can sum it up and we can get our answer. Okay, so now let's see how many times a number can contribute to the answer. Okay, so how many times this number would contribute to the answer? Let's suppose the bigger let's take some bigger number. Okay. Okay, so now how we can find for each individual number? Okay, so let's suppose it was uh, number was let's suppose the number was x. Okay, we want to find for this number x. Okay, so let's suppose this was the ending. This was ending of subsequences. Okay, so if the subsequence is ending at this x, which would contribute towards the answer. So let's suppose that was summation of subsequence which end here. Okay, Okay. So suppose if the number was x minus x by 2. Okay. We will come to this. Okay. So what are the two cases that would contribute towards the answer? Let's suppose every summation till here. What I'm saying that all the subsequence which ends here, and in that subsequence it should contribute. This number should be contributing towards the answer. So that would be one case. Okay, so this is one case. All the subsequence which are ending here, and this number is contributing towards the answer. So let us denote it by A, or we can say sum one. Okay, you are getting what I'm saying? Let be sum one. What this sum one shows? Okay, this sum one denotes all the subsequence that end here, and this number is contributing towards the answer. Okay, so what this sum one shows? All the subsequence that ends here, and it contributes towards the answer. I can't increase this. Okay, no issues. Okay, so what does sum one shows? All the subsequence that end here, and this number is contributing towards the answer. Okay, so now one thing is this. What are the other subsequence which this would be contributing? The other would be which are starting from here. Okay, so if we have calculated all the subsequence which are ending here, what are remaining? The subsequence which are starting from here. Okay, so let's name it sum2. Okay, so all the subsequence which are starting from here. So uh, this number would definitely contribute towards the answer. Okay, so if this is the starting, then no matter what are ahead, means what we take there, this number would be contributing for all the subsequence. So if I start any number, so let me write it up. What is sum2 showing? All the subsequent which start from this index. Okay. So if I know these two answer, all the subsequents that end at this index, and if I know the answer of all the subsequents which start from this index, then I can easily find the answer. The answer would be simply summation of these two for a given index. Okay, this is for ith index. So if I want answer for every index, then that would be summation of the sum1 and sum2, summation of sum1 and sum2 for every index. Summation and sum1 and sum2 of every index I. Okay, so that would be our answer. This would be our final answer. Okay, so now let's try to calculate these two individually. So sum 2 is easy to calculate. Okay, we can say what is sum 2? Every index starting from this index, that would be simply 2 to the power n minus I. Okay, how is this? So let's suppose this is the index. Okay, so how many subsequents can start from 2? Okay, so for this, it's starting from 2. So we have to take 2. Okay, so this is done. Okay, so 2 is done. Okay, so now for every other element, there are two possible cases. Either I can take 5 or I can skip 5. So if I take 5, then it would be 5. If I skip 5, then here it would be nothing. Okay, so for every, I have two options, either take or not take. So it's 2 into 2 into 2 raised to, if this is the nth index and this is the ith index, then the number between this is n minus, how many numbers are there? N minus I. So we have choices for n minus I indexes. Okay. So sum 2 is simply 2 to the power n minus I. Okay, so if we are considering zero base indexing, so it would be n minus 1 minus I. Okay, so this is a sum 2. It is pretty straightforward to calculate. Okay, now the interesting part is what would be the sum 1. Okay, so what is sum 1? We can see sum 1 is all the subsequents that end here. Okay, it should end here and this number should be contributing. So what is the meaning of this? This number should be contributing means suppose suppose the array was suppose if we can form the subsequence something like this. Okay, yes, subsequence ending from this. Okay, so ending and this number should be contributing. So okay, let's suppose we are just taking two elements, 1 and 2. Okay, here the subsequents are ending at 2, but this 2 is not contributing towards the answer because if we take 1, okay, so what can be this number should be 3 or greater than 3. So it's 2, so this number is not actually contributing towards the answer. So what we want? We want the subsequence that ends here. Okay, that means that ends here. Okay, so this is ending, but this number should be contributing towards the answer. Here, this number is not contributing towards the answer. Okay, so this number should not be counted. So how we can find that? So for this, let's suppose we are at number 1. Okay, so now I know all the subsequents ending here. Okay, for example, I know all the subsequents that ends here. Okay, I don't care whether they give me the answer or not. I just care that all the numbers should be. So what I care is I have chosen this number. Okay, so that is just how many ways, how many subsequents that ends here. So means I have chosen this number. Okay, so if I have chosen this number, then what is the next number I can choose so that the answer is included? So if 1 is included, then the next number should be greater than or equal to 3. So it would next number should be greater than 2 into ith number. Okay, so if I know if I know this is 1, then I should find the next number which is greater than 2. So there if there is, let's say, array is something like this. Here there are multiple 1 and 1 2. Okay, so yeah, if I know that what are the subsequents that are ending here. Okay, so if we know, let the number be x, that we know that x subsequents are ending here. So what is the next contributing answer if I take here? So the next answer I should take is 3. Okay, so the next contributing number is 3. So every number between this 1 and 3 I can take or not take. It will not contribute towards my answer. Okay, so what I'm saying, let's suppose this is the array. Okay, so I let's suppose I want all the subsequents that end here. Okay, let's write it down, which include this 1 and 3. Okay, so 1 would be 1. I take all the elements. 1 would be I skip this element. So that would be 1, 2 only. 1 can be I can skip this element also. I can skip this also. So now if I don't skip this and if I skip this, okay, so now if I don't skip this too, okay, there can be many. For now, let's say this. So how many in how many arrays this is contributing towards the answer. So that way we don't care about this. If I know that this is the starting point of my array, okay, this is contributing towards the answer. Okay, so I can know that whatever was the answer here, I can simply add it here also. Okay, let's suppose this index has had 5 subsequents which were ending here. Okay, so answer before this was 5. So there were 5 subsequents which was ending here. Okay, so now if I take this or not take this, it doesn't matter. This answer would be directly coming here. Okay, so in how many ways this number can be contribute towards the answer? Whatever the subsequence was earlier, now I have options for these three numbers. I can take it or I can not take it. Okay, so it's again 2 to the power. Let's say my next bigger element is nx and it is nx minus I. Okay, so you got it. What we were doing? We have to find sum 1 and sum 2. Sum 2 was pretty straightforward. So what is now what we are left with? We are finding for sum 1. So what does sum 1 says? All the subarrays which are ending here. Okay. So if let's say this was array. So in how many subarrays it would contribute towards this? The one would be this means if we take this and this. Now the between choice we don't matter. So it's 2 to the power 2. Okay. The second would be this also. We don't we are fixing this that we are choosing this. Now we can either take it or not take it. So it's 2. Okay. So this would be our answer. Okay. So here it would be 5. Now, if you calculate all the subsequents still here, you will know that every subsequence which ends at 3, that there will be only 5 subsequents only. Okay, which are these 5? One is this, the second is this, the third is this, the fourth is this. Okay, it's 6. 2 to the power 2 plus 2, it's 6. Okay, now if we start from here, this and this. Okay, so in these 6 subarrays, in this subarray also, the 3 is contributing towards the answer. In this subarray also, this 3 is contributing to the answer. In this subsequence also, this 3 is contributing. So total in subsequence, this 3 is contributing towards the answer. Okay, so how can we get till 3 here? Suppose if we know the answer till here, the answer till here was 0. Okay, how 0? Because sorry, it was 1. Because there was just one way this was contributing towards the answer, and that is if we have chosen that element. Okay, so so this one would carry forward to this 3. Okay, so this number would have what would now if we write it down in DP, let's say if I store the answer of this TP. So TP at index I, what it would store? Let's say it would store subsequent ending here in which this is contributing. Okay, so if this is contributing, then I can say that whatever, let's say the next index was, what would be the next index? The next index should be greater than 2 into a of I. Okay, so whatever the value at this index, the next index should be greater than this. So if I know what is the index for that, then I can say that whatever was the answer till here. Okay, so whatever was the answer till here, okay, that would be added, but that would be added how many times? Okay, so it would be added 2 to the power max minus I times. Okay, how is that? So what I'm saying, suppose this n was suppose this one was contributing 5 times. Okay, so there were five. It's not possible, but let's suppose this was the case. Okay, there were two elements in between, and this three was contributing towards five subsequence. Okay, so there were five subsequence which was ending at three. Okay, so how many times this five would be carry forward? If I don't choose any elements, then it would be five. Now, if I choose one here, also then also this seven would still contributing towards this, so it would be plus five. Okay, if I again choose this element also, then also this would be plus 5. So no matter what are the ways to choose this. So how many subsequence I can form from this, in which 3 and 7 should be included. So if there are x numbers in between, then the number of ways are 2 to the power x subsequence. Okay, so what we are doing, we are simply adding this to TP of index. So now let's suppose 8. Okay, so 3 can also contribute towards 8. Okay. 2 can also contribute towards 1, and 1 can also contribute towards 8. Okay, so now let's see the difference. So would this 1 be directly contributing towards 8 or not? The answer would be no. Why? Because if I don't this 1 will also contribute towards 3. Okay. This 1 would also contribute towards 3, 8. Okay. But I would not go and add this to every element. Okay. I would simply add it to 3. Okay, so what would happen? I have added it to 3. Now this 3 can add it to 8. The answer would be still same. Okay, so what I'm saying, if I want all the subsequence ending at 8. Okay, so this 3 is contributing towards the answer. Okay, so this 3 would also carry forward the answer to here. Okay, why I'm saying that? Okay, so that's why we would always choose the next element. So is this clear, everyone? What we are doing? So what we did, we take two someone shows all the subsequence that end here, and this number is contributing towards the answer. Sum 2 shows all the subsequence which start from this index. Okay, so all the subsequence which start from this index is pretty easy to the power n minus 1. Okay, so for now ending at 1, if I start from this point, if I add the answer to 3, means what I'm doing at every point, what I'm doing. Okay, at every point I have how many index, how many subsequence this is adding towards the answer. Okay, so for this many subsequence that are ending here, and in this number is actually contributing towards the answer. Okay, so what I'm doing, I am finding the next element which is greater than this number. So means next qualifying candidate which can contribute towards the answer, and I am adding everything, means the answer till here into 2 to the power next minus I. So why this? Because in between we can form this many, subsequence. Okay, so for that each subsequence also the answer would be added. So if I do this, And whenever I reach at this index, I already have all the subsequence. I would already have all the subsequence which ends here, and this number is contributing towards the answer. So what I can do, I can carry forward that what would be the answer for the next number, and I can assume that this is the starting point. So from here, I can get sum 1. So what would be my sum 1? That would be dp of this index. Okay. So if I will show you the code, you guys will understand better. So what I'm doing, as I said, what we required in our answer, we want two answers. Okay. What do I mean by two answers? Means we want sum 1 and sum 2. Okay. So this is sum 2. Okay. What is sum 2? Whatever answer was still here, means whatever the answer was still here. Sorry. Yes. Okay. So what is the sum 2? Sum 2 is whatever the answer was here. Let's say this answer till starting point of this was the subsequence till here was x. Okay. So what I'm doing, I'm multiplying that by every possible subsequence because that would be answer till here. Okay. So what is sum 1? Sum 1 is if it's contributing towards the answer. Okay. And what is sum 2? Sum 2, you can say it as all the sub-arrays because let's say all the sub-arrays in which this number is not contributing towards the answer. Okay, we can say that. So that would be 2 to the power and as I showed. So that is what I'm doing. So answer is all the subsequent still here plus 1 into 2 to the power. This plus 1 is for because we can add this element also. So if we are adding this 2, so that would also increase our answer. Okay, so what is answer in my code? Answer basically is giving me every subsequence I have formed till now. Okay, I don't care no matter what is the thing. What I'm doing, I'm finding every subsequence I have formed till now. Okay, every answer for every answer till now. Okay, that is my answer. So what I'm doing, I am multiplying it by all the numbers remaining. So answer till now, how much time more it will add? So it will contribute towards the 2 to the power and minus 1. Okay, so that's why this is simply bin power means binomial expansion. So I am multiplying this. Now, what I'm doing, you can see I am I am using upper bound. So what would upper bound will give me? The array is already in increasing order. It's given in the question only. Okay, so the array is increasing only, sorted. Okay, so by upper bound, what I am finding? I am finding the just greater element that is more than twice of this. So what I am finding? I am finding this greater than 2 to the power current number. Okay, so adding I am adding the all the indexes which ends here and this number is contributing towards it. I am adding that to our total count. Actually, this answer is count of total subsequence formed till here and this total is our actual answer. Okay, so what I am doing, I am adding this. What is this? This is our sum 2. Okay, this is the sum 2. So I am adding this sum 2. And what I'm doing, I am finding the upper bound and I am to that index, I am doing this, which I have shown this. Okay, so dp of next plus equal to dp of index into 2 to the power next minus 1. So that is what I'm doing. So these are the total subsequence formed till there. Okay, so into bin power of this. What is this? The number of indexes between the next greater element and this index. Okay, so in the end, what is our answer? Total is our answer. Okay, so that was it for code 4. I hope you guys get it. Okay, so you guys have any doubt? Okay, so let's move forward. Okay, so the next question is reset. Okay, I couldn't solve it. I was not able to solve it in time during the contest. But okay, so how did I approach this problem? Okay, so let's discuss that. Okay, so if you read this question, you are given a tree with n nodes. A non-empty set S of nodes is called good if the following condition holds. There exists some node X in a tree such that for every index Y and Z with Y not equal to Z and Y and Z both belongs to X, it is true that X lies on the path from Y to Z. Okay, so we have to find how many good sets are there in tree. Okay, so what it's saying? Okay, let's yes, yes. Okay, so it's 2100. Okay, so if you are 1800 or 1700 or below, I think you should skip this for now. Okay, you can see, but so what this question is saying, it's saying that we are given some, let's say, some tree. Okay, let's say we are given some tree. So what we have to find? We have to find all the number of good sets. Okay, so what we have to find? Number of good sets. Okay, but here what is the main problem? What is the definition of good set? Any good set means if suppose these two elements are in a good set, then for every element in good set means every element there should at least be one common element between them. Okay, so what does this mean? Let's say so for every pair y and z, y is not equal to z, and y and z belongs to the S, it is true that x lies on path from y to z. Okay, so what this says that it shows that suppose this is the tree. Okay, so we want every good set, and what is the definition of good set? So definition of good set is for all the indices in the good set. If we pick any two, let's suppose these three. Let's suppose these three are part of a good set. Okay, so 1, 3, and 7. So if we pick any two of these, there should be one element that is common to all. Okay, so if I pick 1 and 3, okay, so there is a common element too. Now if I pick any random two numbers from the set, if I pick 1, 7, 1, 3, or 3, 7, okay, or 3, 1, anything, then there is this common number 2 in path between them. Okay, so that is a condition for good set. So we have to find out how many this number of good sets are possible. Okay, so how can we do that? So if you see that instead of calculating every good set, let's for every element, okay, because again we have to simplify this as we have simplified the earlier question. That is, we can't find every possible subset, okay, because there would be 2 raised to power n possible subsets, and we can't find for every one of them. Each one of them would be n square also. Okay, so this is not possible. So instead of this, let's see it in a way we saw the earlier program. Let's try to say if this X is contributing towards answer or not. What I mean is, let's calculate how many numbers are. Let us calculate what we have to calculate. Okay, so this is the max. Okay, for any X or any vertices X, let us calculate what are the subsets which has X as our center. So what was question? What question was asking? Question was asking. Let's suppose this is set. Okay, so the question was asking this X should be same. So Y and Z can be different. Okay, so we have to find how many Y's and Z. This all should belong to a subset. Okay, so if we are given some indices if we have chosen this indices as a subset, then if we take any two as Y and Z, then this X should be in its path. Okay, so what I mean by that, so suppose if we take this as example. Okay, so if I look at this index, okay, how many valid subsets this index will give me? The one's valid subset would be 1 and 5. Okay, because if I take 1 and 5, no matter, I can only take this 1 and 5 as Z and Y. So if I take this both, this would be my center. Okay, I can take 1, I can also take 3 and 5. Then also these 2 would be my center. Okay, now I can't include 1 and 3 in this case because in this case, these 2 would not be center. Okay, so what I am doing for every X, I am counting how many subsets which has X as a center. Because then if I find answer for what would be one more valid case, that would be 2 comma 5 because I can take this also. I can also take 1 and 2. Okay, so these are my cases. So now what we are doing? So as we are contributing, if we look at a vertex individually, then we are calculating how many good sets are forming from these two, which has 2 as its center. Okay, so suppose there are y number of good sets, x number of good sets for these two. There are y number of good sets for this one, and for 5 they are z. So if we simply get summation of all this, and we can get a answer. Okay, so now how can we calculate what are the subsets which has x as our center? Okay, so how can we calculate this? Okay, let us first calculate every. So for this, what I was doing, let me show you where I got wrong. Okay, then we will move to correct answer. So as I said, what we were calculating, we have to calculate this. So what I was doing, suppose this is the, let's suppose this is one tree, this is one tree, and this is one tree. Okay. So if we are calculating for this x, we know that I can't take s- any two vertices from this same tree because then the path between them would not include this tree, this vertex. Okay. So I know that I have to take one from this, any one from this, and any one from this. Okay. This was clear that if I take any one from this, okay, and anything from this and anything from this, I would definitely get this as an answer. because if I take any path between them, then this would cross from this vertex only. Okay, this index only. Okay, so that was clear. So what I was doing, I was counting this plus one, and plus one. So what I was doing, I was counting everything. Let's say this tree had two vertices, this tree had three vertices, and this tree has four vertices. Okay, so how many possible things I can take from this? Either I pick one vertices, or I pick these vertices, or I don't pick any vertices. So that's why plus one. Plus one was for not picking anything. Okay, so then what would be my answer? My answer would be simply count plus one for all the childrens. Okay, let's see all the children. Okay, but now this would also include one case, that would be if I not pick anything from this. So I was subtracting that one case. Okay, but now what if I don't pick anything from this both? Then also, if the subset only contains this one, then this is not the case. So that's why I was subtracting n minus one also. Okay, because suppose this has two index. So there were cases where by counting this, I was also counting the case where none was selected. Okay, none was selected, or only one was selected. Okay, so for this, there is just one case, and for choosing only one, there are n minus one cases. Okay, so I also subtracted that. Okay, but now what if I want to include this x also? So for this x, what I was doing, I was again doing the same. But now this, what was first? This was for including x, not including x. Okay, then I would again loop the same for x. You can see I looped one for not including x. Then I again run this for including x. Okay, so next time for including x. So till now, four was connected to 5. So till now, I was calculating all the cases which don't include 3 but has 3 as a center. So that would be 1 into 1 into 1. Sorry, 2 from here, 2 from here, 2 from here. So that would be 8 cases. What were these 8 cases if I pick these 2 and these 2? If I pick these 2 and these 5. Okay, if I pick all 3. So there were total 8 cases. You can write it down. Either I pick all 3, or I pick only one. Okay, I pick only this one, or if I pick only this one. If I pick these 2, if I pick these 2, and if I pick these 2, and one was if I pick everything. Okay, so these 8 cases are possible if I don't include these 3. But here you can see these cases are invalid. Why invalid? Because it just contains 1. So if I am just taking the sets 4, then it would not have 3 as its center. What I am calculating, I am calculating only all the all the sets which have 3 as a center. Okay, so this would not include in my answer. So that's why I was subtracting n minus 1. What is n minus 1? N minus 1 is this. All the elements which only has one element in it. Okay, and one case was anything is not selected. So I was subtracting this. So this was the answer. This was the answer for all the cases which don't include 3. Now, what if I include 3? So then all these cases would be similar, but I in this all cases I would include 3. So if I include 3, then I so what I'm including these 3 to every cases. Now you can see I can take all these cases. Okay. So for the second loop, I don't want to remove everything. Okay. So initially it also gave me correct for the, if I show you, if we just do what I showed you, uh, sorry, we are calculating this 2 times. Okay, so okay, so what I was doing for this first loop, as I showed, what I was doing, I was taking all the subsets which don't include this as a what we say, which don't have this as our center, which has this as a center, but that doesn't include this. So that was this case, and one was where I am including these 3. Okay, so this should give me the answer. But now, what is the thing which we are missing? We are missing the case. So what we are missing? We are missing the case like we have counted many things twice. Okay, so like suppose this was the tree. Okay, so what I showed was giving me answer correct answer for small cases. But what if this was the case? Okay, so I have created 2, 5. I would have considered this set 2, 5, and 7 one time when I am counting these 4, and I would also have considered this case one time when I'm counting for 3. Okay, because these sets are common in common for both the index. Okay, so that's why I was counting some index multiple times. Okay, so that's why it was giving me false answer. So that's why this approach was wrong. Okay, so now let's move on to what is the correct approach. What should be the correct approach? Okay, so the correct approach should be let us count all the subsets. Okay, which are of length 1. So all the subsets which are of length 1, there can be n subsets. That is, if we choose this element only. Okay, then this is a valid subset. You can see that in question also. Okay, if you see, if I take the question from, this is the first problem. 1 is connected to and 2 is connected to 3. So how many subset it can form? Okay, everything good. Okay, so how many it can form? It can either form 1 or 2 or 3. I'm writing the subsets. Okay, every subsets 1 and 2, 1 and 3, and 2 and 3. Okay, and one would be 1, 2, and 3. So this should be our answer. Okay, these are 7 valid subsets. Okay, and these all are valid because no subset is defying this condition. All three subsets satisfies this condition. Okay, so these are answer. So what we are calculating every subset of size 1. So there are just n subsets of size 1. Now let's calculate every subset of size 2. So if we pick any two element, that would give us a subset. If I take 2 and 3, it would give me a subset. If I take 2 and 4, it would give me a subset. So what I can do, NC2. From any n elements, I can pick any two number. So that would be n into n minus 1 by 2. Okay, so what is this n minus 1 by 2? This is my subset, every subset which has 2. Okay, now let's look for cases where the answer is greater than 2 or greater than 3. Okay, so if I have to look for greater than 3, so now what we have to do, now we can look it for each vertex. Okay, what I mean by each vertex, let's suppose this was a vertex. Okay, so if this has two branches, okay, if it has only one branch, then definitely we can't form anything. We can't form any three. Let's what we say, we can't form anything, any subset greater than 3 which has 3 this element as a center. Okay, so what our question is, how many we have calculated for 1, we have calculated for 3 2. So now what we have to calculate, we have to calculate for 3. Okay, how many valid subsets are there of size greater than 3 which satisfies these two conditions. Okay, now for that, let us say that this number x, okay, this is a, now let's calculate for every subset, let's calculate for every vertices how many subset is this a part of. Okay, so now what we are calculating, we are calculating that how many subsets this number is part of, okay, that are greater than 3. Okay, so if this number has to be part of something, okay, let's say x. Okay, if I want, okay, so if I want for this x, what I want, how many there are good subsets, how many good subset includes x. Of size greater than 3. Okay, so now the only question remains is to find this. Now, how can we find this? That is the main question. Okay, so one thing, if I pick this, I know that I have to include this element. Okay, so if I want, let's suppose I want for answer for 3. Okay, so if I know I have to pick this one element, so how many elements are left? These two elements. Now, is there a way that if I choose these two elements from only a single branch, okay, let's suppose there are two elements here. So can I pick two elements from a single branch? No. Why? Because then uh, it would give me false for this, because now there is no common point between y and z. I mean, for y and z, the common point would be something. Let's say this was the case. Okay, what we are looking for x. Or let's suppose there is a y connected to x and there is z connected to y. So can I pick this both element as my subset for three elements? No. Why? Because if I look for a path y and z, that doesn't include a midpoint. If I look for y and x and z, then there is a midpoint x, y. So now this should be consistent for every subset of this, every vertex in this subset. So this would not be possible because if I pick x and z, it would give me y. But if I pick y and z, then it would give me y only. Sorry, it would give me z. Okay, so this is not possible. Okay, so this is not possible. So I can't pick two elements from a same subset. So whatever number I have to find, I have to choose it from different subsets only. So if this is the x and I am including x, then whatever other numbers are there, it should be from different branches only. Okay, so now we would add our thing which I was talking about. Now we can add our count plus 1. Okay, that is if we take from here, if we take from here, and if we take from here. Okay, and if you do that, so if you look at a solution, let's see what he has do. So see what he has done. For each branch, we either choose no node or exactly one node from that branch. Okay, this is Java code. Let me show you something. C++. Okay, so you can see in this code. Okay, so what he has done, what they have done, they are doing the DFS. First, as I said, the answer is n plus n into n minus 1 by 2. That is for this case. Okay, 1 and 2. Now let's see what they have done for. Let's see what they have done for the case for this greater than equal to 3. Let's see what they have done for this case. Okay, so they are finding the size of everything. Okay, ways of 1 and 2, 1, 1, 0, 0. Page of 10, it shows one way. There is only one way to pick an empty subset. So what does this space define for J less than 2? That's the number of ways to picking exactly J vertices from first I component and vertex per component. Okay, so I got it. So it was same as I was telling you. So what they are doing, let's suppose this is X. Okay, so we have already counted everything with size 1 and size 2. Now what we are looking for, greater than equal to size 3. Okay, so if let's suppose, so is everything fine? Hello. Okay, so I think everything is fine. Okay, so what we have to do now? We have to find all the subsets that are greater than size 3. Okay, because we have already calculated subsets of size 1 and 2. So how can we do that? Okay, for this, let us look at what vertex is individually. Okay, so what we are doing? Let's suppose there is a vertex X. Now let's find out how many subsets would be there which passes through X. Okay, so how many subsets size greater than 3 that passes through X? Okay, just a minute. Hello. Okay, so where were we? Okay, so till here everything was correct. Okay, so we if we want a size greater than 3, then we can't take both of same subset. Means we can't take two elements from same branch. Okay, so now what is our problem? So if suppose there are k branches of any vertex, so the path to so for path that should include k. So that means that both the vertices should be from different uh, what we say, both the vertices should be from different branches. Okay, so for every branch we have two options. Either we can take it or not take it. Now suppose we take it. Suppose we decide not to take from anything from this branch. Then the number of ways would be same only. Okay, because we are not doing anything. Now the case only changes when we add something, when we decide to take from this branch. So if we decide to take from this branch, then what is at most we can take one only. So how many possibility is there? So it is size of this branch. Okay. So suppose there are two vertices in this branch. So we can take any one from that only, because at most we can take one only. So there are two chances. So till now, if we have selected 0, so then we can take. So now we would add that to our tool. So now how many? Sorry, number of ways to pick 0 would be 0 only. What would have changed? So how many number? What would have changed? We would have changed this. So now if we select from this only, so let's suppose this was the size for this index, so it would be multiplied by ways of 0. That would be initially 1, because there is just one way to select nothing. Okay, so if this is the first branch we are selecting, then this would be the case. Now if we have selected one branch, what was the number of ways before? So if we want to pick 2 and we want to pick 1 from this, then whatever the answer was earlier, what was the answer for picking one way earlier? That was way 1. So this would include size would be way 1. Okay. For 3 also, it would add size into way 2. Okay. And what we will add to our answer? We will only add this way 3 column. Why this 3? Because everything less than 3 we have already included in our answer by calculating this n into n minus 1 by 2. So that is what they are doing here. So what they are doing here, number of ways would be always 1. What would be the number of ways to select 1? That would be whatever the number of ways for selecting 1. And if we don't select anything from this is this. And if we select from this branch, then it would add the size of this branch. Similarly, for number of ways for 2. If we don't select anything from this, then it would be same only. But if we if we select anything, then it would be this. Now for greater than 3, okay. So this was till 2. Now for this, it is greater than 3. So it would be number of ways to pick 3 plus number of ways to pick 3 uh, from earlier also and this also. So that would be into S of I plus, if earlier we were only selected 2. So that would be ways of I minus 1 into 2 into S of I. Okay. So this would give us our answer. So basically what we are doing, if I let's try to code this. I hope you got what I was saying. So what we did, let us summarize. So I already explained why why I was thinking like this and why it was wrong. Okay, because we were counting some subsets double the more than one time. Okay, So now what was the fix for this? So instead of counting this way, let us count this way. That is, let us count everything, every subset with size 1. Let us count every subset with size 2. And let us count every subset with size 3. So for 1, it was easy. There were n options. For 2, also it was easy. It was for n or n minus 1 by 2 options. Okay. For greater than equal to 3. So now this was the case which was most difficult. Okay. So now we have to look for, now we can, what we can do. Now we were for size greater than equal to 3. We were looking for every index this. Okay. So let's suppose this was x and this had 4 branches. Now for every x, what we are trying to do. So for every x, we want greater than 3. Okay. So what we are doing, we are maintaining a array way of 2, 3 and greater than 3. Okay. So for 1, it was one way that we don't select anything. Okay. Now if from this, for every branch, we have only 2 options. Either we take it or we not take it. Why only 2 options? Because if we take both indices, both vertices from same branch, then the path between them would not include this x. And what we are counting? We are counting for something which includes this x. Okay. So how can we do that? So we can either take 1 or 0. So if we take 0, then everything would be same. So that's why this condition you can see. So if we decide not to take anything from this branch, then it would be that only. But if we decide to take anything, then then the choices for this is size of this branch. Okay. So if the size of this branch is x, let's say s, then the ways of 0 would be, okay, so then the ways of 0 would be increased. Ways of 0 would be same only, that is 1. Because to select 0 thing, there is just one way. But what would be ways of 1? Ways of 1 would be, ways of 1 would be ways of 1 plus this size. Okay. Now what would be ways of 2? Whatever it was earlier. Okay, if we decide not to take anything from this branch, then it would be same. But if we decide to take from this branch, then it would be number of ways 2 of plus earlier, which was way 1. Okay. So if I am at this index, then whatever possible way till this index into size of this index. Okay, you can see it here. Okay, so these are the transitions it follows. Okay, and for greater than 3, either we don't take anything from this, or either we take 1 from this and 2 from previously, or either we take this and all the possible ways we can take earlier. Okay, and what we want only ways of I3. Okay, so we would add these to our answer. Okay, so and in the end, if we give the summation of everything, then we would get our answer. So what in this code also you can see, he is adding n. So n is for everything with size 1. For everything with size 2, it's n into n minus 1 by 2. Now in he has written a code for DFS. In DFS, what it is doing, uh, he's saying that what are the ways for choosing anything, it is zero. For choosing one, it is one. If we decide to choose this element itself, okay, so that is one and zero zero. So now what he's doing, he is updating his answer with every iteration. That is, for every first he would iterate to this branch, then he would iterate to this branch, then to this branch, then to this branch. So with every iteration, what he's doing, he's updating its answer. Okay, so how his answer is updated? So base 3 is getting multiplied by base 3. That would only increase the. So why base 3 is multiplying with base 3? Because suppose there were three subsets of size 3, then we are allowed to take the subsets of size 4. Okay, so that's why this 3 is storing everything greater than 3. 2 is only storing 2, but 3 is storing everything greater than 3. So that's why base 3 is equal to base 3 into x plus 1. What is x? X is size of the subarray. Okay, and why plus 1? Because if we decide to want to choose this, that's why plus 1. Okay, and plus what if we have chosen previously only base 2? So that are base 2 into this x. Okay, so similarly base 2 are also updating based on if we don't choose anything, then base 2 would be same. Plus if we decide to choose one from this, then earlier one would be considered here. Okay, and similarly for base 1. Okay, now he is updating everything for this. Okay, and this is for its parent. Okay, so if we are doing a DFS, so we would have come to this from anything above. So this is also considered as a branch. Okay, so that's why we are also doing it for its parent. And then what we are adding to our answer, we are adding all the what we are adding. We are adding ways greater than equal to 3 only. Okay, because we have already calculated for 1 and 2. So that way we got our answer. Okay, so that was it for today. I hope you guys enjoyed it. If you have any questions, we can take now. If not, then we can end it here. Okay, so I think there are no questions left. So should we end here? Okay, so let's end here. Okay, so see you in the next stream. Okay, so that was it for today, guys. So we have okay, so that was how many questions we have discussed today. We have discussed these 5 questions. Okay, okay, so let's see you in the next video. Actually, these questions are pretty tough. Okay, so if you are not able to do it, then don't get demotivated. Like I was not able to do it because these questions are tough. I know the submissions are pretty high, but that's because of the AI nowadays. Okay, so otherwise you can see that this question was actually pretty good question. Okay, but because of this submission, this question is considered a low rated, but that's not true. Okay, so these questions were tough. So if you are not able to do it, so don't get demotivated. Just keep practicing. Okay, because of this AI stuff, these questions have so much high acceptance rate. Okay, so that's it for today.